Hi there! If you've been to this channel before, you're already familiar with videos about 8-bit computers and vintage programming, but today we have something different. I'm going to visit this half of my workbench where we're going to do a full restoration, both electronic and aesthetic, of this beautiful tube radio, the Loewe Opta Rheinperle 4716W from 1957. So buckle up and let's restore this beauty. The front is not that bad. That magic eye tube we're gonna have to replace, but it got all the knobs. The dial is in perfect condition. You can see that this knob which turns for treble sounds, it's fine, but the one for the bass is not. The buttons are good, the piano buttons. We can move the dial here on different bands, so that's all good. It's got, of course, a lot of dust, and it has some dents, especially on the corners. I'm not sure what I'm gonna do with this. I don't know if it's worth refinishing for this. Let me turn it around and show you the other side. This is the back of the unit. Still got the FM antenna. We can still make most of the lettering here. We can make it out. We got a ruined cable that has got to be replaced. And if we unplug this here, it's a bit stuck. Okay, if we unplug this here, we can check the unit inside. Oh boy, is this dirty. You can see that we have the remains of generations of insects and God knows what else in here. We can see some caps, some paper caps, not this one, some paper caps here that have to go. There's some sort of crust. I don't know what this is. It doesn't look like crust. It looks like some sort of, I don't know, insect droppings or something. We have to test this transformer to see if it's all good. But this is promising. Let's take a look underneath. Underneath, it is secured by 2 screws. These 2. And once we remove them, it should be possible to slide this away. Oh, that's interesting. There's an old playing card yeah, that someone lost long ago. And a lot of dust. The dust of the ages. We can see some circuit board over there. So the next step is now take some vacuum cleaner and my trusty cleaning box and get this cleaned up. And here we can see the little brother, the Bella Luxus. So let's remove this card from here. It's a really old playing card. God knows from when. And this is my assistant. Okay, so the initial cleanup is done. And this doesn't need to be very good. It is not, but at least most of the dust is off and the tubes are removed. Now the next thing is to get this chassis out of the cabinet so we can start looking into the electronics parts. So in order to get this chassis out, what we need to do is we need to remove that magic eye tube, but that's probably just turning a knob until it comes loose, and this hooked by this cable here. The antenna is already connected only to the chassis and only plugs via this plug. So the only thing we need to use the soldering iron is to get these speaker connections out, and then we can remove probably like 4 screws that are one here, that one here, and 2 in the front. And once we have done that, we can probably just slide the chassis out of the cabinet. So, as expected, after desoldering the contacts of the speaker and removing the bottom screws, the entire chassis could be slid out of the cabinet. The cabinet is filthy. There's a lot of dirt that we can now clean. And also we can access this part of the chassis, the front part. So there's a lot of cleaning to be done here. I'm working on the cleaning, but before that I would like to show you some measurements I started doing even before we took the radio off the chassis. One of the first things we need to check is whether the power coming, this lamp is not right. So okay, this isn't good. So one of the first things we need to check is that the power coming through mains and through the power on switch here. So when power is on, we should have current coming here, passing through the primary of the mains transformer and coming back here through one of the taps of the different voltages and going through the fuse here. So we should have current here. So in order to test that, we have here a multimeter with the 2 prongs of the mains power, and here you can see it's in continuity mode. So what we need to do is then turn on the radio, and we have no continuity. So I've tried multiple times measuring continuity in the primary of this transformer, but still nothing. I've tried cleaning the fuse after we removed the chassis from the radio to clean the fuse. I have replaced it with a brand new fuse. I have bypassed the fuse with this thing. Of course, we are not powering this to the mains, so that should be fine, at least for testing continuity. But yeah, basically no continuity in the primary. So what I think I'm doing is, so this is where the secondary goes into the selenium rectifier that's under this board. So these 2 wires here are the secondary windings with 200 plus volts. So this is the one that what I plan doing here is I want to disconnect one of these wires. So we're basically not powering the selenium rectifier, so we're not powering anything here. All we would be doing is running tension. I'm gonna use the variac and my dim bulb tester to control the process so we don't end up with any major disaster. I'm going to put back the fuse here, and I'm going to slowly power the radio up, but with this winding disconnected. So we should have power through the primary and through the secondary that feeds this 7-volt rail here. This circuit that feeds the 2 lamps, which I don't know whether they work or not. This one doesn't look like it does. This maybe does, maybe doesn't. And also the heaters of the different valves. So yeah, I'm suspecting that this transformer may be not working, but I cannot test with just a continuity test. It's not working, so I'm gonna give it a try to just powering the thing up. Okay, so something good seems to have happened here. I actually had to bypass the fuse because the contacts are really dirty, and that's breaking you don't have continuity between the two prongs. I really have to clean this copper thing this here. But what you see is that now I have the variac around 110, 120 volts, 138 actually to be precise. And I am measuring here in the secondary of the heaters and the lamps, the dial lamps, and we have, as expected, 4.3 volts. So we need 7 if we get this thing to have around to 20 to 30 volts. We should have around 7 volts there. So let me just give it a bit more juice here. So now we have 157, 160 volts, and we have 7 here in the secondary. So let me go to 225, and here we get the 7 volts. So this should be fine. So that's very good. So what we know that we have to do is really clean those contacts of the fuse until we have continuity here, and then we have to put back in that wire that are removed, basically, so the rest of the radio is going to be powered on. And as I kind of expected, none of the dial lamps are glowing, so we're gonna have to replace them. After cleaning up very well with the Dremel tool those two prongs, now we have again the fuse, a new fuse, a 1 amp fuse, because it calls for a 0.71, which I don't have. And now you see we have the variac and the dim bulb tester again. And the thing, I was turning the radio, trying to turn the radio on with the piano keys, but actually it's that's not how this radio works. You have here a switch in this pot. So when you turn this on, so you see, you hear the click here, right? So check the multimeter, 0, so no volts. Now when we turn it on, so with around 225 volts, we have 7 volts in the secondary of the heaters. So it's all good. The transformer is working. I have checked both secondaries for the low voltage and the high voltage secondaries. So it's turning on and off. Still have that little wire disconnected, so it's not powering up the rest of the radio. So now that we check this, we can move forward. The next step here is testing the audio transformer. So we already know that the power transformer is doing well, and there's a an output transformer, now audio transformer, that's underneath the chassis. I cannot show you right now, but it's around this area of the chassis. So what we see here is that I can get the light better. So if you look at this diagram, this is the output valve, the EL84. So this one, the EL84. So the anode goes to the output transformer. It's this guy here. So and this one is connected, the secondary of this transformer is connected to the speaker. So if we can get a signal at this point here at the anode of the EL84 and get it to make a sound on the speaker, we know it's the radio is doing all right. So fortunately, we don't need to turn the radio on to do that. So first thing, I have connected these wires that I had desoldered to the speaker, respecting the polarity. And now I have here a signal generator generating a 440 hertz audio signal at 3 volts of amplitude. And it is connected, the ground is connected to the chassis of the radio. And here I have a probe of sorts. So this resistor here, you can ignore it. I actually only have this so I can plunge this leg into one of the valve pins. So the pin that we are looking for is the anode of the EL84. So it's like 1, 2, 3, it's the third one from the beginning. But because this diagram is showing the valve from the bottom, we have to sort of mirror this. So it's going to be the third one from the beginning, but on this side here. So it's the third one from the beginning on this side. So it should be this one. You see, starting here, 1, 2, 3. So this is the anode. So if we put here that signal, I expect to hear a 400 Hertz tone on the speaker, and that will tell us that the output generator is doing fine. Not the generator, the output transformer. So let's see if that works. Do you hear that? So here's our audio signal. So that tells us that the output generator is doing just fine. What do we know so far? The power transformer, primary, we know it's working all the way through the fuse. The only thing is that there is a cap here that is known as the death cap. It's a capacitor that is meant to filter out interference from going back into the mains. It's not important these days as it was in the past, but still we need to replace this guy, and we need to replace it with a safety cap that if it ever goes bad, it's going to open instead of shorting. And it's called the death cap because it can be quite charged, and if you touch even the radio when it's off and this thing is charged, can give you a nasty shock. So the secondary, we know the low voltage railing that goes to the heaters and the lamps is all right, but the lamps need to be replaced. And the high voltage secondary is fine, going to the selenium rectifier. And the selenium rectifier, we probably need to replace it with a silicon equivalent because we cannot trust this thing at this point. Also, all these caps that we see in the diagram, all the electrolytics, all the paper and wax caps, they need to be replaced. We know that the anode of the EL84 going to the output transformer is fine. The primary of the output transformer is fine. The secondary of the output transformer is also fine. The speaker is also fine. So this section here, we know it's good. And this section here, we already get it to work and identify the few parts that need to be replaced. So the next part of the job is identifying all the caps that need to go here, and also checking all the transistors and other components, checking all the coils for continuity. So now it's the most time-consuming part of the job, and I'm going to show you why we have to recap. So if we take a look at the radio again, you see this is the death cap, and this is a wax cap that is completely melted. You see it's spilled all its guts on the board, so this is not working at all. Like this one is the same, and this guy here is the same, and here we have some paper wax caps that look a little better, although they are quite dirty, but still, yeah, you cannot trust these guys to work after so long. I mean, paper caps, wax caps, this kind of thing. Sorry, I dropped something here. So these guys, they tend to really lose their properties. The paper ones, what happens that humidity gets inside the layers and break down the layers and break down the original chemical properties. And the wax ones with heat, they tend to melt and spill their guts out, like the poor guys over there. So now we need to go over the entire radio and replace all the capacitors and other components that beg replacing before even trying to power up this thing. In order to identify the caps that we have to change, I have spent a few hours going through the diagram and marking with red ink the caps that I kind of know we have to change, in this case the cylinder rectifier and the lamps. So some of them we already discussed, they are obvious, others like this electrolytics, so all the electrolytics have to go. In the electrolytics we can identify them because they have certain special markings, like this one. And some other paper caps, certain values we know that they are paper caps in radius of this time and age. Some of them I'm still suspicious, I'm not sure if they are. So many of them are difficult to find because they are underneath the chassis, which we don't have a lot of access right now. Later we will. I have done some tinkering with documents here. I took photos of the radio and then I tried to identify each one of the caps by looking at their values and checking the diagram. Also, this is part of the service manual, and it's a description of the circuit board with all the contacts and which components go where. But this is seen from the bottom up, right? So this is the original document, which I have here somewhere. So this is the original document. So it shows the circuit board from the bottom up. But when we look at it from this angle, we are seeing top down, right? So what I have done is I have printed the document, flipped, so we can have the right angle. And then actually what I did is using an image editor, because all these labels, they were like reading mirrored. So I have removed them and I have retyped them, checking with the original diagram to make sure that they are correct. So now I have something that I can use to compare this with this. So that helped identify a lot of these guys. So I already know that I have many caps that I have to change even before I try to make any power up test. Also, something else I have done, I have removed the dial and the panel that's behind the dial, that's like a reflector for the lights. So here's the dial, it's a glass dial, and now we can clean it. And by the way, you notice that here at this corner we have stuck some pieces of very, very old rubber that have already gone bad. So I have to think a little bit about what I'm putting there. And this metal piece here, this is screwed here with 2 screws. So basically this reflects the light from those 2 lamps and make the dial, I mean, we can see all this lettering clearly on the dial when the radio is turned on. Also, by removing this, you see that we have more dirt, that we have better access to clean now, which means that I will continue. I will start probably replacing soon some of these caps, and we will continue the cleaning because you see that the radio is still very dirty. Also, oh, I forgot to mention. So this thing here is the FM unit. Here's where the ECC 855, I'm sorry, the ECC 85 valve goes. And at the bottom of this, you have a circuit board. That's this one. It's underneath here, which we cannot see right now in this position of the radio. But this board is protected by this case to block radio interference. It's just a metal case. I have removed it by just removing one screw, and now I can clean it. You can see it's pretty dirty. And probably I'll just clean it and put it back because I don't think I'll need access to that part of the radio. But that's where we are right now. And let's go for the next steps. I've had some progress here in the last few days. One thing I started doing is replacing the caps. So you can see this one is new, this one is new, this one, which by the way, it's this ERO brand, which was the same brand of before. This here, that's between the filter caps and this coil. And also this one is new. And finally this one is new. So I have already replaced all the capacitors that are on the top of the chassis. And here's the caps that I removed. Some like this. This is the worst one. This was sandwiched between those two cans, and it really like spilled its guts out. Now it looks actually a bit tidier because I just cut the parts that had melted away. And but you see it's even like deformed. It's not a perfect cylinder. It was kind of pushing those cans to the side, so that's really bad. Some like you see it was spilling its guts, but even worse than this one. And also we had some electrolytics here, and I have measured some of these, like the electrolytics, and they all are drifted. And some like this, it's not even possible to measure, and it's not even useful to do that. This is really just junk by now. So that's one thing. So I have ordered some parts, and they are here. And this is one of the lamps that came with the radio. So this is an E10 lamp base. And this one, there are some markings here, probably hard to read, but basically they say it's a 7-volt lamp, 0.3 amps. And this is a lamp that I bought. So these are actually 10-volt lamps, while this should be a 7-volt lamp. So it will not shine very bright. But actually, I like that these are for a different voltage, a higher voltage, because that means that I'm not going to stress these lamps depending on what happens. But this is for a different project, so ignore this one. So, and here I have some caps, some stuff that I'm gonna need. So what I'm thinking of doing now is replacing the lamps, and perhaps even putting the tubes back. And we still have this disconnected cable here. This wire is unsoldered, which means that the whole high voltage circuit is powered off, so nothing is going to happen in the radio if I turn it on, except that I expect that the lamps will shine, and also that the tubes, the heaters, will be turned on, so we won't get any behavior other than seeing a filament lighting up inside the tubes. But I think it's an interesting test to do, to see if this whole circuit here is indeed as well as I think it is, and also to check if we have any of the tubes with a burn heater. Of course, even if all the heaters are good, doesn't mean that the tubes are good, because they might not be behaving as expected. But it's a first test, because if the filament is broken, then the tube is gone. So at least we will be able to rule that out, and also test the lamps. And by the way, you see here that many of these caps that were marked as red, that had to be replaced, now they have this circle, this green circle, and these are the markings that I make to remind myself which caps I have already replaced. So we have, and by the way, I forgot to mark this one here. So we have 1, 2, 3, 4, 5, 6, 7 caps replaced, and I think there's at least another 7, 8 to replace. They are in bit harder places to reach, but yeah, that's good progress. So why don't we turn on this radio now with the disconnected wire, and we try to get the lamps and the tubes to light up. So I have put here the lamps. Here they are. So the lamps, 1, 2 lamps. And I have again I have the multimeter in the low voltage rail here. So I'm gonna turn on the variac, and before I turn on the dim bulb tester, I'm going to just lower the light here so we can see it. So here goes nothing. And voila, we got light, and there should be 7 volts. We have 689, 69. That's very, very good. So now I'll put the tubes in and see what happens. All the tubes are in now, according to the schematic. So here goes nothing. So we have again the lamps here, and we see here's the, get a pencil. So here's the output, audio output tube, the EL84, shining bright. And we can see here the heater of the, I think this is the ECH81. The EF89, it's a bit harder to see. Don't know how all this shows in the video, but it is, I see the heater is there. This is the EM80. The ECC85 is shining bright. The EABC80, I can see also the heaters here and there. Oh, and here, I think you can see from this angle well the EF89 ones. So all these tubes light up. Right now they are just glorified light bulbs because there's no B+, there's no high voltage going on and carrying the audio signal. And by the way, something I forgot to mention, you can see that I cleaned these cans. I could not do a perfect job, but I used like steel wool with some isopropyl alcohol, and I have scrubbed this, and then I have really, like, with a vacuum cleaner, got rid of all the debris. Some areas here where I could really like buff this. This is looking great. Here I could clean a bit. Here it's really hard, especially because we have all these coils here with all this delicate stuff going around. So I don't think it's worth trying to clean this perfectly. I'm just trying to do a decent job within reason. So anyway, now we know, and I'm gonna mark these things with my green marker. So let me take this. So we know that this entire secondary circuit here with the lamps and the heaters of all these tubes. So they're represented here, right? This filament here is the heater of the tube. So all the filaments of all these tubes are fine. And now what we have to do is, of course, replace the missing caps. Before we do anything, we have to change more, replace of the capacitors that are, like, of course, unreliable, for sure unreliable. And then we have to see what to do about the selenium rectifier and about the filter caps here, one day at a time. The next step now is to replace the capacitors that are underneath the chassis, and those may be quite hard to reach. So some of them are here on the side of the radio. Here they are easier, but some of them are really like lurking in the innards of the radio. It can be like, you see there's a couple paper ones there. So that can be quite hard with the radio standing on its upright position. So what I use in these cases is a frame like this one that's made out of wood. It could be a metal one, but basically it must be a sturdy frame that you need to bolt to the radio chassis using the same holes that we have for the screws that hold the chassis to the cabinet. So the next step is to take this frame and mount the chassis on that frame so we can have access to the bottom part of the chassis with ease to use the soldering iron. Here we have the result. The chassis is mounted on the wooden frames, and now we can flip it as I'm about to show you. Now we have access to the bottom of the chassis. It's way easier to come here and replace caps like this one. It's still going to be a challenge because they are quite buried in there, but now it's doable. Also to touch the silicone rectifier that's there, that box over here. And still there's one cap that is pretty inaccessible somewhere. Yeah, there it is, behind this metal frame. You can see there, piece of it sticking out. Maybe that I have to unscrew parts of the piano keys mechanism so we can have access to that one, but this is of course much easier now. It was quite a challenge, but I have replaced all the capacitors. So here on the side, let me get some more light. You see there's 3 orange ones, 3 blue ones. The orange ones are 4.7 nanofarads and the blue ones 2.2 nanofarads. And here access was quite challenging. So this is a 0.1 microfarad one. So I have another one here and here that have been replaced. These are the coupling caps. And here's another one. By the way, this one I decided, I don't know if you can see there that we still have the paper one, but it's currently disconnected. So yeah, it was hard to remove it. And anyway, I thought it would be interesting to leave one of the original caps, even if disconnected, for historical reference. And I have taken advantage of this hole here to get the leg of the cap here, because otherwise I would have to disassemble this whole unit in order to get there, and that would be really a pain. But I'm happy. I have already tested continuity. It looks like everything is good. So now I have replaced all the caps. Here they are, the ones that were just removed. I think I replaced something like 16 caps in total between the top and the bottom of the chassis. And now with the recap, we are actually ready for perhaps what I think is the most exciting part of the project, which is trying to turn this thing on for the first time and see what happens. I will reconnect that selenium rectifier. By the way, here's the selenium rectifier, this box here. I will reconnect that wire that I had disconnected, and I will actually try turning this thing on without touching the filter caps and without touching the selenium rectifier, and see what happens. In many cases, both the filter capacitors and the selenium rectifier are still fine, And my philosophy is, unless there is a big safety risk, I don't replace stuff just because. I replace because it's got to be replaced, because it's very, very likely not working well. So let's give it a try. So the valves are back in the radio, and we are connected to the variac, connected to the dim bulb tester. We have the buttons back here because I don't want to touch live metal on the chassis when this thing is turned on. I have here on the side, on the DC output of the selenium rectifier, I have the multimeter connected. So here we can see the AC that is coming in, and here we're gonna see the DC. And I think there's a chance, I forgot to mention the speaker is connected to the original speaker over there. I have resoldered this connection. We cannot see it really well from here there, but let me try to show from a different angle. Yeah, this connection is resoldered. So for the first time in God knows how many years, we're gonna try powering up this thing again. And I'm gonna go easy. I'm gonna start, and here the variac, it's around what? Let me put it around 60 volts to begin with. So turning the variac. And here I am limiting with first bulb of a 40-watt bulb. So this one, you're limiting. It's all good. So here goes nothing. Oh, let me turn the radio on, of course. Turn the lamp off. It's easier to see. Okay, so 49 volts, 60, 50 volts. And we have approximately the same voltage DC, which probably makes sense. So with full 220 volts, we expect 235 in the B plus. So yeah, we have now 61 there, and 61 AC, and 65, almost 66 DC. So that sounds about right. So let's crank this up. So we have now 80 something AC, 90 something DC. You can see some attempt to glow from the lamps. I cannot see the heaters turning on just yet, at least not from this light. So let's give it some more juice now. So yeah, we start having some glow in the light bulb, which is dimming slowly. So that's nice. We have 110 volts AC and 120 DC. And we have more glow in the lamps here. So let's gently give it some more power. So around, actually it should be around 150 volts AC, but we only have 121 here, probably because we have to give it a bit more current. So I'll turn this 60-watt lamp as well. So now we jump to 163, and we have sound. I'll try putting a radio to see what happens. So this should be FM. And by the way, we are connected to an FM antenna. This is my antenna over there. Now I see some glow in the heaters. So still not enough juice. So let's go to 180. This is too silent, honestly. Let me put in medium wave. Still very quiet. We don't seem to have any short or anything, because yeah, the lamps are not glowing, so that's good. I mean, those lamps, right, of the dim bulb tester. So let's crank this up to 220. Let's give more. Oops, this is a bit too much. 230 volts. And we're still limiting, but we're giving it a lot of power. So that's not 1.6 amps, that's 0.16. The B plus is a bit low, right? So this may be an issue with the selenium rectifier. Whoops. Sounds like it's trying to receive something. This is AM, medium wave. So let me try FM. Whoa! Okay, so we still have stuff to see here. I think that B plus is way too low. So I guess there's something, perhaps we need to really replace the selenium rectifier. But I'm very happy. It seems that the radio is alive. So let me think a little bit what's the next step, and I will record what I do.